Okay, this is our section of guided notes for quadratic formula. Okay, what we're doing in this last little bit. So our objective is to use the quadratic formula to solve quadratic equations and implement it in an application problem. We're not really going to do a lot of application problems, but mostly I just want you guys to know how to use the quadratic formula and where we get our numbers from. So here's our quadratic formula, okay? Everyone should have this written down from the other day. To use quadratic formula, we need equations to be in standard form. Okay, this is standard form. That means that it's ax squared plus bx plus c equals 0. So you have to have everything on the left side of our equation equal to 0. And then we can figure out what our a, b, and c are to plug them in the formula. So in our first example, so I'm going to keep the quadratic formula right at the top of the screen so we can look at it. But here is our ax squared plus bx plus c equals 0. It's in standard form, so that's easy. Our a is 3. Okay, see how these are in the same spot? B is 5. And C is -7. We need to pay attention to negatives, okay? So make sure you include the negatives. Oh, now we're going to plug this into our quadratic formula. So x is equal to opposite b, so we have a negative b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So up here, wherever you see b, let's do it this way. So wherever you see b, that's where you're going to put your b. Wherever you see a, that's where you put a. And wherever you see c, that's where you put your c. Now let's do some solving. So first, let's focus on inside of our radical. So inside we have 5 squared minus 4 times 3 times -7. Well, in our calculator we get 25 minus 4 times 3 times -7 minus a -84. Two negatives, remember that makes a positive, so 25 plus 84 is 109. So all of this turns to 109. And then this is all over 6. Okay? Now, let's look. 109 cannot be reduced, so this is our final answer. So square root of 109 can't reduce. So x is equal to a -5 plus square root of 109 over 6. And it's also equal to a -5 minus square root of 109 over 6. See how this plus or minus gave us two different answers? So it gave us a plus here and a minus there. So we have two x values. Okay. So let's draw a line. So for our next problem, this is ax squared plus bx plus c equals 0. We are not in standard form. Okay. So not standard form. So we need to get this side to be 0. We want 0. So minus 2x from both sides. So we get 2x squared plus 3, or 2x squared minus 2x plus 3 equals 0. So good, we got the 0 we want. Now it's standard form. So a is equal to 2, b is equal to negative 2, c is equal to 3. So plug it in. So x is equal to positive 2. Because it's a negative, and up here we have a negative, so it's positive, plus or minus the square root of negative 2 squared minus 4 times a times c all over 2a. So x is equal to 2 plus or minus the square root of 4 minus 24 all over 4. So x is equal to 2 plus or minus the square root of negative 20 all over 4. Negative means imaginary. So we got to solve for imaginary. Okay? So if we broke this down, so square root of negative 20, that's the same as the square root of negative 1 times 4 times 5. So our x value is equal to 2 plus or minus 2i square root of 5 all over 4. And then we can reduce this down a little bit more. I am running out of room totally. So let's get rid of some of this stuff. Okay, so let's go up here now. So x is equal to 1 plus or minus I square root of 5 over 2. See, we divided all the 2's out. So x is equal to, now our brackets, 1 plus I square root of 5 over 2. And our other one is 1 minus I square root of 5 over 2. Oops. So that's our x value. So this is our two x's, okay? So we still had two x's, and they're both imaginary numbers. So if you flip the page, in a quadratic expression, the discriminant is what we keep inside the radical. So this is your discriminant. So b squared minus 4ac is used to find the number of solutions. So right here inside the radical. That's your discriminant. So if inside your radical is positive, it's greater than 0, then you have two solutions. That's positive. If it's equal to 0, then you have one solution. And if it's less than 0, then it has no real solutions. As in, so this means that if it's less than 0, that means it's negative. And if it has no real solutions, that means that you have imaginary numbers. So for imaginary, remember, we use I. So what we just did on the back page, see how this was positive? We got two solutions. Right here was negative. We had imaginary numbers. So we had two imaginary solutions. Because they both have an I means they're imaginary. So we can have a couple examples if we just want to see how many solutions it has. If we don't even want to solve, we just want to know how many solutions. So we could do our discriminant. So discriminant is the b squared minus 4ac. So our a is 1, our b is negative 2, c is 4. So negative 2 squared minus 4 times 1 times 4, and that gives us negative 12. So this is imaginary. There are no real solutions. So when A is equal to, in this problem, negative 3, B is equal to 5, and C is equal to negative 1. So let's use our discriminant equation. So 5 squared minus 4 times negative 3 times negative 1. And again, guys, I'm just plugging that right in here. So negative 3, negative 1, and 5. So when we solve this, we get positive 13, so there's 2 real solutions. And our last one, right here, A is negative 1, B is negative 10, and C is negative 25. So A, let's fill this in. So we got negative 10 squared minus 4 times negative 25 times negative 1. Plug that all in, and we get 0, which means that this equation has one solution. So right now, we just solved to see if there's only 1, 2, or no solutions. We didn't actually solve to find out what those solutions are, but that's just a quick thing that we can check just by using our discriminant. Okay, so that's our discriminant. So now we know a couple ways to solve quadratic equations. Oh, sorry, I got the hiccups, guys. So we use factoring. So that's when we factored and we were able to find some answers. And then the way we just learned now was quadratic formula, which always works, whereas factoring only sometimes works. Factoring, we use the big X method. Quadratic formula is the formula we just did in this video.